that gives us Thursday to just practice, practice, practice. So eccentricity. Without a graph on hand, how could you explain to someone else how elliptical a particular ellipse is? So what would you say about choice A? How could you describe the shape of that to someone else? Very circular, right? It might not be a perfect circle, but it's very circular. What about that next one, B? Yeah, it's very elongated or elliptical. So it says in figure A, the ellipse might easily be mistaken for a circle. In a circle, the foci are equal to the center, right? There's one focal point, the center. So therefore, when the foci are extremely close to the center, it's difficult to make a visual distinction between a circle and an ellipse. Early astronomers had a difficult time when studying planetary orbits whose foci were relatively close to their centers. But now we can use the concept of eccentricity. So eccentricity is the ratio of C divided by A. Why is it C divided by A? Well, C is the distance from the center to a focus, and A is the center to a vertex of the major axis. So we care about C and A because we just said the closer the focus is to the center, the more circular it is, the closer it is out on the major axis to one of the vertices, the more elongated it's going to be, right? So up here in A, right, here's my center. My foci are probably really close to the center. But on B, it's really elongated. The foci are probably out here further. So how is that ratio going to change? C is really small divided by a bigger number, you're going to get a really small fraction. But when C is really big, right, like let's say this is 7 and this vertex is at 8. 7/8 is going to approach what? It's going to approach 1. So it says for an ellipse that's nearly circular, the foci are close to the center, so the ratio will be close to 0. For a circle, the eccentricity is 0. For an elongated ellipse, the foci are close to the vertex. Sorry, typo. For an elongated ellipse, the foci are close to the vertex, and the ratio C divided by A approaches 1. Eccentricity can never equal 1, because that would be a perfectly flat pancake, right? So if you've got your really long ellipse, and here's C, and here's, right? You can't actually have it flat as a pancake, because this would be on top of this, and it'd be a straight line. So you can never have an eccentricity of 1. You can never have an eccentricity of 4 or 90, right? Eccentricity is going to be between 0 and 1. So eccentricity, if you get an eccentricity of 2, you did something wrong. All right, so here's just, let's find the eccentricity of each ellipse and explain if they will be really elongated or if they'll be short and fat like a circle. So we've got our A value, right? A is 3. And we've got our A value over here. A would be the square root of 20, whatever that is. I need to solve for my C values, right? Because I need to take C and divide by A to find eccentricity. So you're going to have to use that Pythagorean identity that A squared equals B squared plus C squared. And you're going to plug in 9 and you're going to plug in 4, and that tells you C squared in this example is 5, right? So C is the square root of 5. So C squared is 5, C is the square root of 5. So our calculation will be whatever the square root of 5 divided by 3 is on our calculator. So what is square root of 5 divided by 3? Square root of 5 divided by 3, 0.75, right? If I rounded it. So that's approaching 1, right? So this is slightly elongated, right? It's closer to an ellipse than it is to a circle, for sure. 0.01 would be really circular. See if you can do your calculation for ellipse B. So you're going to do a squared equals b squared plus c squared. Plug in your a squared and your b squared values and solve for c. And then take c divided by a. And I want to know which one is more elongated or which one is more eccentric. Have you ever heard the word eccentric before? Anyone have an eccentric neighbor? You know, like the lady with 9 cats or the people that are a little bit odd. Eccentric, right? Means you're a little bit odd. So an ellipse is kind of odd compared to a circle. A little bit eccentric. So minus 15 on both sides. C squared is 5. So C again is the square root of 5, like it was on the other example. So I'm going to take the square root of 5 and divide by the square root of 20 this time and see what I get. 0.5. Is that what you got? So our eccentricity is 0.5 for this ellipse. So if you just had to compare the two, which one is more elongated? A. 0.75 is closer to 1 than 0.5, but they're both fairly elliptical, right? You're not going to mistake these for a circle. A circle would be like 0.1 maybe, or 0.01 would get mistaken for a circle. So eccentricity is kind of another formula that you've got. C divided by A. And if you understand eccentricity, you understand why you're using C and A as your ratio, right? Because it's how stretched out you are on that major axis. So try these other two examples on the back page. So find the eccentricity of the ellipse. They've labeled some points for you. You're going to have to figure out your A value and your C value to figure out the eccentricity. And here are the answers to the eccentricity problems on the back.